Now let's take a look at using the Piezospeaker within the Parallax Robotics Kit to play tones. One of the things, so what you're going to do first is you're going to wire up this little speaker that uses the Piezospeaker. And what this thing is it's based upon the piezoelectric effect, which means there are some materials where when you apply an AC voltage to them, they will actually vibrate. And when something vibrates, it'll move the air around it. So we can use this to build miniature speakers. So what we do is we apply a voltage to it back and forth, and we can vibrate this. And as long as we vibrate at a frequency that's within our audible range, the pressure waves created by that vibration will be interpreted as sound by our ears. So go ahead and wire this up. It's a polarized device, so it's going to have a plus on one side, so you got to make sure to connect that directly to pin 4 and then wire the other terminal to ground. And so what you'll see is there's pins that span this gap in here. And then what we can do is we can just do traditional digital outputs or digital writes to kind of mess around with this device and see what we can do. Okay, so after you wire that up, go ahead and fire up a new Arduino sketch. And the first thing that I'm going to do is I'm going to save off my sketch, and I will say File, Save. And I'm going to put this in our working directory that we've been using, which is on our desktop Arduino. And I'm going to call this Chapter 3 Activity 3 Tones. And this is just to match the parallax tutorial that we're kind of following along on. Okay, so I'll go ahead and bring up my serial monitor while we have it going. And let's begin. Okay, so the first thing we're going to do is this is on pin 4, so we just want to write, basically write a high and a low to it and see what happens. So let's go ahead and get into our program. And the first thing that I'm going to do is I always set up my port here, my serial port, so that I can monitor what's going on. And so I'll do a print line, and we'll say starting tone program, and that tells me that the program is actually running. And now let's just write some highs and lows to pin 4. So if you recall, at this point we know that we can use the command pin mode, and we can set a pin number to either an input or an output. So if I do pin mode 4 comma output, that converts pin 4 into an output, and I can actually then write highs and lows to it. And then I can do digital write, and I'll do pin 4, and I can simply say high. And notice that when I do it in all caps, it turns blue, and I can write a high to it. And then why don't we do high-low and see what happens. So why don't we write a high and then delay like 1,000 milliseconds, which is a second, and then let's do a digital write low and then delay 1,000 seconds. Okay, so let's go ahead and compile this and download it and make sure that everything is working. Digital write, misspelled digital. So digital write, save, and compile. And let's see what happens here. So I got my Arduino connected, and I got my speaker right here. And I should see when the program starts, it will print. So we're getting close. Starting tone program. Okay, great. So did it do anything? Okay, so if you reset it, one of the things you'll notice is it clicks. So if you, I'm going to put the microphone as close as I can to this. You'll hear it click. And what's going on is that it basically vibrates. It not vibrates. It like forces it one way and then leaves it there. Okay. So I can actually say, okay, well, let's hear that clicking a little bit more. So what if I move this into my loop? Okay, and now I'm just going to sit there and write high, write low, write high, write low. Let's go ahead and save that and see what happens. And we'll see if I can hear anything happening. Okay, so I'm downloading it and it's starting the program. And you'll notice it's clicking. So it's just sitting there going click, 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 click. And I tried to put my microphone right on top of it so you could hear it, but you'll be able to hear this thing. It should be just sitting there going click, 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 click. And what's happening is that material is flipping one way and then flipping back, but it's going at a very low, what we call frequency. It's moving back and forth so slow that all we hear is clicks. It's not really creating a tone. So let's think a little bit about what it means to create a frequency. So we'd actually like to go high and low at a frequency that is something we can hear. So let's think about what we're actually sending to pin 4. What we're doing is we're sending it a high, then we're delaying, sending a low, sending a high, sending a low. Well, if you look at a periodic waveform, we define the frequency of that waveform as how many times a signal repeats per second. So in the units are hertz. So if I had a 1 hertz signal, I would be repeating every 1 second. We've actually created with this program, we've created a 2 hertz, or excuse me, a half a hertz signal, because we go high for a second, then we go low for a second, high for a second, low for a second. So our period, which is the time of each repeating interval, is actually 2 seconds. So we go high for a second, low for a second, high for a second, low for a second. The period and the frequency are related in that the frequency is 1 over the period. So we've created what we would call a half a hertz signal, and it's got a period of 2 seconds. Now, why is this interesting? Well, we can't really hear anything that's slow. I mean, it's really, really slow. So if you look at the frequencies that we can actually hear with our ears, they lie somewhere between 20 hertz all the way up to 20 kilohertz. So 20 hertz is like really low bass, so like 60 hertz is bass, and then it goes all the way up to 20 kilohertz is super, super high pitch, and some people can't even hear it. And then like dogs would be out here in this range in the supersonic. Okay, so what does that mean? What it means is that we should change our frequency of this, and let's do one that's like let's say a kilohertz, for example. So a kilohertz would be would have a period of 1, or no, let's just do something in the audible range. So let's do like 100 and 100. Okay, so that means my period is 200, and it's going to have a frequency which is, let's see what that would be. It would be 1 divided by 200. It would have a frequency 200 milliseconds. Frequency like 5. Even that's horrible. Let's do let's do like 10. Okay, so I'm gonna go 10 milliseconds, 10 milliseconds, high, 10 milliseconds, low, and then let's download that and let's see what happens here. Okay, so all right, so now I'm starting to hear something, and it's kind of this. I'll move it over to the microphone. It's a very low frequency. You can still almost hear it clicking, but it's 50 hertz. Okay, so that's good. What would happen if I went all the way as fast as I could and said, I want to actually do something that has a high time of 1 millisecond and a high time or low time of 1 millisecond? So let's download that and see what happens. And if I said, what's the frequency of that? I'd go 1 divided by 2 milliseconds, and that's more like 500 hertz. So now listen to this. That's about middle C, right? Middle C is about 440. Well, okay, so now we're sitting here and it's like we finally have created a tone which is pretty good. You know what the problem is though? We cannot use the delay signal anymore or the delay function. The delay function only allows you to have an unsigned integer here. So I am not allowed to go in here and go 0.1 and make this go any higher in frequency. So I'm actually at the extent of what I can do, which, you know, that's fine too, because this was pretty easy. I just got in a loop and I was able to make a 500 hertz signal. And it's buzzing, so I can have this in there and life is good, okay? Now, if I wanted to do something that was a little bit better, one of the things that happens is Arduino has provided a function for us, and it's called tone. So we can just, you don't even have to include a library or a method, you just say tone, and this will output a particular frequency to the buzzer, or to a pin actually. And the way that you configure the arguments is you can either have 2 arguments. One is the pin, and then one is the frequency, and you give the frequency in hertz. So it's really simple. And then the other one is you can do pin, frequency, and duration, and the duration is how long it will go before it turns off. So if you wanted pin and frequency, it would just stay on forever, and if you did the duration, it would actually go off. Okay, so let's take a look at how we could use this. So what I'd like to do, one of the things I'll do is to, if I leave the program running, I'll just pull the ground wire out to get it to stop making a noise, and then I'll plug it back in when I go. Okay, so let's take a look at how we could use the tone signal. So I'm going to come down here, and I'm done with this right here, so I'm just going to comment that out. So I'm going to go comment. So I didn't lose it, but I commented it out. And now what I'm going to do is I'm going to come back up, and let's just go. What's cool about the tone is you don't even need to have you don't even need to configure the pin. It'll configure the pin for you. So I'm just going to come in and I'm just going to type tone pin 4, and let's go 100 hertz, and let's do it for 100 milliseconds. Okay, and the way to think about this is I could go along and say print, just sent 100 hertz, and if I did this, life is good. So I can go ahead and download this, and this will run one time. Okay, print, oops, you go serial.print, and I'm going to go ahead and run this, and let's see what happens. So I'm going to send out 100 hertz signal to this using the tone, and it should go for 100 milliseconds. Okay, so plug my guy back in and hit reset, and it went. And you just hear this little knit, knit. Okay, life is good. So that was interesting. One of the cool things about the tone, though, is that you could potentially put another tone right after it that was 200 and have it go for 100. Now 100 milliseconds is not very long, so let's make it 500 milliseconds, so that's like a half a second. And this now creates an interesting thing. The tone function will allow you, it sets it up in the background, and then it allows you to move to the next statement. Okay, so if in this example, what would happen is it would say, send out a 100 hertz signal on pin 4 for 500 milliseconds. Then immediately it would go to here and say, send out a signal that's 200 hertz for 500. So what happens is these would actually override each other. You would actually not even get this one. And it's made this way so that you can actually turn the tone on and then go do something else, but it doesn't work real well when you're trying to send multiple tones. So in this situation, I would want to put like a delay in here just so that I give it time to actually send the tones. So let's see what happens when I do these two tones. So now what I should get is I'll get something that actually plays a 100 hertz tone for half a second, then a 200. Okay, so let's see what happens. Okay, did you hear that? So it's great. Alright, so I got these tones playing. And you can actually just copy and paste if you want. Let's do something like this. This will be kind of cool. I can actually I can put this function on the same line. And now that it's pretty easy to copy and paste and change things. What if I did this? Let's just get a whole bunch of tones in here. So let's make this like 3, 4, 5, 6. And so I can actually cycle through these tones. Let's listen to this now. So this becomes pretty cool. Do you hear that? So life is good. Okay, so we're actually being able to play a sequence of tones. Okay, so now I can put these at the beginning of my programs and play a little cool tone. As I move around, I can do some cool stuff. And I can even do more advanced stuff, which we'll see now. What if I wanted to send like a sweeping range of frequencies to this? So let's play around. At this point, we have the programming constructs where we can do things like, why don't we create a for loop and let's cycle through the for loop and let's send a whole bunch of different tones to the speaker and ramp it up to some high frequency and see if we can make something that sounds cool. Okay, so we don't need this anymore. Let's go ahead and uncomment that. And then what we'll do, so at this mode, we're not using the pin out, we're not using this. We're not even using the loop down here, so we're going to come right here and let's do the following. So let's think about a for loop. So I'm going to come along for loop, and I'm going to have this loop variable I. Now I need to define it, so I'm going to go int I, and that'll allow me to have this little local variable within my setup loop. And this is we're gonna loop through. Why don't we set this to something like 100, okay? And then let's stay in the loop as long as I is less than or equal to 5,000. And then each time through the loop, let's go ahead and just say I is equal to I plus 1. Okay? I always write I is equal to I plus... No. I is equal to I plus 100. Okay? So now let's think about what is going to happen here. So I start a loop and a loop. What I can do, this is pretty neat. What if I said tone, and I called the function tone, pin 4, and instead of giving it a hard-coded frequency like up here, I'm going to give it my loop variable I. And now the reason I did that is because every time through this for loop, it'll start off at 100, so it'll be 100, and then let's play tone. Then the next time through it'll increment by 100, so the next time through it'll be 200, and then it'll increment by 100, and it'll go 300, 400, 500, 600, and it'll actually scale all the way up until it reaches to 5,000, which is 5,000 or 5 kilohertz, which is pretty high pitch. So then the only thing really left to do is put a little delay in here. So let's delay it like 50 milliseconds, and then remember now we need to delay 50 milliseconds to actually allow it to go. So it'll go for 50 milliseconds and stop, but we need to allow it to play for that long. So let's just see what happens when I do this. So let me save this baby and do that. Okay, so I'm going to move this up to my mic. That was awesome. All right, that was pretty cool. So that went way up. In 5,000, I mean, that's pretty high. I mean, we could even make it 6,000 if we wanted to see how high it would go, or even higher than that. But I'll tell you what, why don't we do something even neater than that? Let's take it all the way up and then take it all the way down, just while we have that we can copy and paste. So I do a for loop where I scale all the way up to 6,000. Let's go a little higher. And then let's go down to, actually, let's leave it there. This time now I'm going to have a for loop after it's done, and I'm going to start at 6,000. And what I'm going to do is I'm going to say continue as long as I is greater than or equal to the low value, which will be 100, and then we'll say I is equal to I minus 100. So this loop right here, this for loop, after it scales up to 6,000 kilohertz or 6 kilohertz, it'll come down here and it'll start at 6 kilohertz, and it'll actually go down by 100 all the way down, and it should go up and then down. Okay, so let's see if that'll work. Alright, so I'm going to hold it up here. Hit reset. Perfect. Okay, cool. And you know, it's kind of interesting because sometimes when you scroll through the tones, some of the tones don't sound exactly like what you would think, and it just has to do with kind of the structural properties of the buzzer. I mean, these are not perfect speakers. This is a really inexpensive little thing that we're using to make tones. But that was pretty cool. I mean, you could have it every time you power up, you can go all the way up, all the way down, so that's kind of neat. Let me show you one last thing that I think is kind of neat. If you wanted to, let's say, play a song, okay, you could actually create a song using a concept of an array. So let me let me comment these babies out. An array is, it's basically a data structure which can hold a series of basically a series of things. So what I can do is, let me show you how to create an array. I'm going to have int I, which is my loop variable. What if I did int and I called it note? So this is going to follow along note. And then what I can do is I use curly brackets in the Arduino programming language, and I can actually just put a list in here, and let's just type in some values. And I'm gonna kind of copy what they do in the tutorial, but I'll put them in a different order so that I kind of go, you know, one, this is a note, and then I'll go a little bit higher, and then this is a note, and then a little bit higher. And these frequencies correspond to the scales of a musical scale. Then let's do like a 1568, and this is not a song by any means. This is just a bunch of notes. So let's just put all these in there. So I'm gonna go da 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 da. Let's put this one below. Okay, so I'll put this right here. And yeah, you can make up a song at some point. But okay, so I've created this thing called note, which is an array, and it holds 1, 2, 3, 4, 5, 6, 7, 8 things. The reason I do that is because check out what I can do in a for loop. I can say for I, and now I'm going to use the loop variable I as an index. So if I said, for example, if I typed, note index 0, that would go and it would grab the first element, the first piece of information in that array. If I said note 3, it would grab 0, 1, 2, 3. It would grab this guy right here. Okay, so I'm going to use this loop variable I to actually be the index for the array. So check out how to do this. I'm going to start off with I is equal to 0, and I'm going to say for I, stay in the loop as long as I is less than 8, and then I'm going to say I is equal to I plus 1. And then I'll open up my loop, and here I go. So now think about what I'm going to do here. Now I am going to come along, and I am going to say tone. I'm going to call the tone, and then I'm going to say pin 4, and then now I'm going to give it the frequency. But I'm going to give it the frequency by calling this array. So I can say note, and then the index is going to be I. Okay. All right. So life is good. And then let's do it for like 500 milliseconds just so we can hear it, and then we'll go delay 500 in order to let it actually complete. All right, so let's think about that. Is that going to work? We will see. All right, so I fire that baby up, and let's hold it up to the microphone. One more time. Perfect. Okay, so now those are just, we're just playing around at this point, but you can see how you could create an actual song. You could actually create an array that holds all the notes of the song, and then you might say, well, some notes I need to have longer or, shorter. You could actually create another array, which would be like int, and then like you could call it note length, and you could actually have a corresponding array down here, which would be, whatever, 200 milliseconds, and I want that note for 400 milliseconds, and then da-da-da-da. And then down here, you could actually come along and say, instead of giving a hard-coded delay here, you could call it note length and index it again. So you could take a song and you could get all its notes from it, and you could just play a full-blown thing using this little cheap Piezospeaker. Okay, so that's it. Go ahead and give that a try.